Hey everybody. I'm still setting up right now, so it should take me like another 2 minutes before we start. So just hang tight, and I should be back in a short bit. Okay. All right, guys. Well, show started. I just am already set to go. Hope you all are excited to join in on the stream. Apologies if it doesn't seem as professional. This is my second go around, so bear with me. So, just a quick introduction. This is the Free Code Camp Columbus live stream. It's our second live stream, as I mentioned before. My name is Dan Stockham. I'm one of the administrators of the group. I help run the group. Free Code Camp Columbus is a study group for folks that come together to basically get help on the Free Code Camp curriculum. So we're not necessarily the official Free Code Camp, but we were just like-minded individuals who are learning how to code using Free Code Camp. We've been around for going on 4 years now. I think we started, no, actually, I think 5 years. We started back in 2015. Back then, we were just getting together at coffee shops. We had coffee and code, and then we also booked library venues. Um, yeah, and we kind of just took off from there. Eventually, we were able to secure venues. We actually have two meetups at two well-known establishments, Improving Enterprise and used to be Cardinal Solutions, but they have changed over to Insight. Um, very grateful for their space, and we normally hold pair programming sessions and also do talks. I hope you guys can hear me. If you can hear me, just put a number 2 in the chat, and it might be a little loud because uh, my mic. I actually had a wireless headset, but the problem was the mic would work and sometimes it wouldn't work. So I had this bad boy in the storage, and I brought it out. Figured it would probably be a better option. Um, oh, I'm not getting anything yet. I don't think anybody can hear me. So yeah. Actually, I'm gonna bring out my agenda and again. Apologies. I got on. I was trying to figure all this stuff out right before the live stream. So, all right. I want to get my agenda out, and once I get it out, I can talk about some stuff that we're gonna go over. Hopefully, it'll be a longer stream. I think it all depends on how far we get through the agenda. Let's see. What do I do with my agenda? Oh, I'm looking at the wrong one. That's why. Almost there. Personally, for me, I wish I had something more exciting to talk about, but it's been a pretty boring and uneventful week. Obviously, working from home, nothing, nothing exciting. Everyone's kind of stuck indoors, or they can't really do anything other than go out to the park and take a hike, and of course, not shake hands and give hugs. uh, yeah, so I wish I could talk more about myself, but I don't really have anything to talk about. But I do have a lot of stuff to talk about regarding Free Code Camp and some other cool development stuff that I love to get to. But once I get my agenda, and then also I also was going to do a kind of like a small tutorial as well. But of course, I got to get my agenda for that. I'm almost there. Here we go. Cool. So, so this is what we're going to talk about today. We're going to talk about some things about Free Code Camp, some of the recent newsworthy items that came from either Free Code Camp or Quincy Larson, because Quincy Larson is basically Free Code Camp. He may deny it, but he's the face. No matter That's so pretty face he has. Uh, no offense to him, but he's a great guy. He's awesome. Um, he's a lot of cool stuff that he basically got the ball rolling, and then the world the global community kind of stepped in, helped contribute and collaborate. So some stuff from Free Code Camp. There's also some conferences I want to talk about because I think it's like totally worth it, and it's like the best value you can get. It's free. It's really awesome. And then finally, I want to talk about Git. It's the title of it is Casually Explained. Git Casually Explained. So yeah, I'm super stoked to talk about it. It's not supposed to be like a formal tutorial. It's more of just casually explaining what Git is, because I know there's a lot of newbies out there that uh, let's see up here. I got a question here. It says, a little odd joining. The broadcast is now live. It appeared 1/10 away up page. Then message saying I have to watch YouTube, but I'm in. Yeah. So it's really weird. Rocket Chat does give you the ability to put up live streams. However, there's two ways you can do it, and then there's the hard way that takes time, and then there's the already out of the box solution. The out of box solution is actually embedding a YouTube live stream link. So if you click on the live stream, and let me do this. Sorry guys, I'm like I said, it's my second live stream, so I'm still trying to figure out OBS. Let's see. I think it's window capture. Yeah, here we go. I want to make this smaller so my face isn't in the way. So what you'll notice is a lot of the rooms in Rocket Chat. This is similar to Slack, but not so much in the sense that there's actually more functionality for it being free. So you can actually embed live streams into the channels, and if you look at the upper right hand corner, there's a little Wi-Fi signal. It's like a really, I mean, it looks like a Wi-Fi symbol that you typically see, and there's a little red dot. If you click on that, it actually pops out the live stream, and it has the actual live stream right here. I could click play. I don't really want to do that because last time I did that, it crashed OBS, and I think I know why. But essentially, you can watch the live stream from Rocket Chat. It shouldn't it shouldn't tell you to go to YouTube. That's a little unusual. Oh, you know what? Hold on, let me check something here. Oh, you're right. Ah, oh, jeez. We actually ran into this issue a while back on our first live stream. Basically, YouTube won't let you live stream unless you monetize, and there was another reason why that there was you have to you have to enable a monetization, and then you also have to have I think you have to have so many views or something like that. But it worked for us last time. I don't know why it's not working this time. Uh, huh. That's really weird. Sorry about that, guys. I thought that would work. But going back on Rocket Chat, you can have your own packaged live streaming server that you can just host from Rocket Chat. The thing is, it's something you have to implement yourself. You have to have a media server, and you have to enable live streaming capabilities on your server, and that takes work. And unfortunately, as much as much as we have a hardcore group of members part of our team, and always wanted to improve the group. There's only so much time in the day, so that's definitely on our to-do list to get that incorporated. Oh, okay, cool. Yeah, yeah, yeah. You're definitely watching the right thing. If you go on YouTube, there's actually there's one recorded live stream from last month. I think that was the end of April, and then the second one should be live right now. Yeah, sorry about all the jankiness. It's this is actually a new chat server, and we're trying to get everything pulled into this server because right now everything's kind of spread apart. Yeah. So yeah, without further ado, let me just go ahead and I'll knock out some of the announcements and from Free Code Camp. So Free Code Camp has been doing a lot of live streams lately, and one of them is basically like a virtual mini conference. This their May Summit. They actually just recently had it today. It was the 13th, and oh, oh, I don't want to reveal the magic. Hold on. Okay, guys, sorry. There we go. And then make my face really big. There we go. Cool. So yeah, Free Code Camp recently had a conference, and it was basically like a virtual conference. So they had a couple of speakers, and then Florin Pop. He happens to be a live streamer, and he actually live streams the challenges he does on Free Code Camp, and he's gotten pretty far. In fact, he's gotten as far as I believe it's the quality assurance section and APIs. So he's interesting to watch. He kind of he confessed he is actually a developer, but not by not, it doesn't he's not as experienced as you think he'd be, and he's actually gotten pretty far within the curriculum. So he's interesting to watch. I highly behoove you if you have some time to check it out. There's some really cool stuff. Um, Outside of Free Code Camp, we have the Jamstack conference hosted by Netlify. That's going to be happening on May 27th, May 28th. I can post, actually, in fact, let me post some links for you guys. So, this is the virtual conference, and this includes the agenda and the keynote speakers. Super exciting. I definitely would check it out, especially if you're a newer developer, because one thing you'll notice with a lot of the jobs in Columbus, and it's not big yet, but it is going to be big, is a lot of bigger companies are going to move over to cloud. And that means a lot of AWS, a lot of Azure. Also, you got a lot of these new frameworks are coming out, or if you can call it that, it's just I think it's just a paradigm. Jamstack. Jamstack is basically I believe it's JavaScript, APIs, and I believe Mongo. It's mostly database related, and essentially, the cool thing about it is you're building your front end, and that's it. The back end is already handled. You can leverage tools like Contentful. You can use leverage tools like Netlify, who's hosting the conference, and you can basically you could essentially also leverage other APIs that connect to your front end. For instance, a good example would be if you're building a nutrition app, you can use the USDA public API to pull in nutritional information. That's just one of the APIs you can use, but it's just a paradigm that's being used. It's a relatively new thing. They're using typically what you see in a Jamstack is like a static site generator. That would be like Gatsby.js, which is basically a static site generator that you can hook into something like Netlify, and you can build a full stack project, like a legitimate web application, in a short period of time. Um, Really cool. I would definitely check it out. There's some real opportunities right there. Um, Now, I'm gonna warn you. I know there's some people are not exactly PC, and I'm not a particular person. When I say PC, politically correct, and it's a relatively politically correct conference, but you can look past that. There's a lot of good information. So just a heads up. I know some folks don't like PC culture, but you gotta kind of take, you gotta give and take. So yeah, definitely check that out. And I forgot to give you a link. I've Here. I'll give you the May Summit link too, and I'll include that in the chat. And also, if anybody is watching us from YouTube, a lot of the conversation we prefer to have over on Rocket Chat, just because eventually we want to move over everything over. So like we're gonna get rid of Slack. Slack's just going to be dropped off, and then all the chat logs, all the users will be moved over to Rocket Chat. And essentially the website will be moved over as well, and everything will be all integrated. That's the vision that our group wants to. That's the vision that we have for the group. Because right now we're really spread out, really spread out. Um, yeah. So yeah, and there's one more link I want to share, and this is actually the schedule. If you just want to check out the schedule for Jamstack, it's a conference. Cool. All right. Okay, so those are the two things I want to get out of the way first because I think they're noteworthy. Oh, I'm sorry. One more thing. There's a new runtime environment coming out, and it's called Dino.js. And it's like, well, okay, what's Dino.js? Well, Dino.js is actually a runtime environment using JavaScript and TypeScript. A whole lot like Node, but better. The original creator, Node, essentially created Dino.js to express some of the issues that Node.js had. There's a lot of talk of this being the next big thing. I don't know about that. There's a lot of frameworks that come out there that are supposed to be the next big thing, but turned out they're not. So I don't know. Maybe because it's the same guy who did Node.js. So yeah, it's totally worth checking out. In fact, I included a link on our Slack channel. Let me include it on the Rocket Chat if you're ever in the mood to check this out. I think it's totally worth it. I mean, any technology is totally worth checking out. All right, cool. So got that out of the way. Yeah, that's all the updates I wanted to share. So now we're going to move on to. Oh shoot, where's my agenda? There we go. Now I want to move on to do like to talk about Git. So this is me casually explaining Git. The reason why I wanted to do this is because I know a lot of newer devs out there. They they don't really they want to know what employers are looking for. They really want to know exactly. Like, okay, all right, what's going to take to get me hired? What are the key skills I need to know? And you could tell them it's like, oh, well, you need to know this language, you need to know that language, you got to know something, you have a basic computer science fundamentals, you got to know your data structures, all that good stuff. But really, uh, the, the, that's not as important, and it's because different languages they serve different needs, right? But they all are. Someone can call me out on this, but they're all essentially the same. So it doesn't really matter where you start language wise. You just really want to stick with it and get good. However, what's universal is basically version control and having a good fundamental understanding how a version control system works. Now, there's different types of version control systems out there, but there's only one particular one I like to talk about tonight on this live stream, and just to kind of give a good explanation what it is, and that's distributed version control systems, which is Git. So, all right, distributed version control systems. Okay, Dan, I thought you said you're going to casually explain this. I promise, I am. So, what I mean by a distributed version control system is there's not one central repository that developers will work off of. In fact, each developer has a copy of the repository, their very own copy. And Git gives you the capability of syncing those repositories up. In fact, and this is from the Wikipedia. This is a Wikipedia quote. So take it as is. Git is a distributed version control system for tracking changes in source code during software development, designed for coordinating work among programmers, but it can be used to track changes in any set of files. Its goals include speed, data integrity, support for distributed nonlinear workflows. So this means that there isn't one central let me back up. That basically explains what a version control system is. But specifically, a distributed version control system, this means that there's no one central repository of the source code. There are multiple copies of the repository being used by the development team. As I explained before, each developer on the team has their copy. Um, yeah. Oh, cool. John mentioned there's another JavaScript conference coming up. It's JavaScript Remote Conference 2020. So that's cool. That's really awesome. And again, this is great because a lot of these conferences are remote, and that means like you don't have to like travel anywhere. You don't have to convince your boss to use the training budget. Well, maybe. I think there is another JS conference that's going on. It's like a $75 a pop, but hey, training budgets. Jeez, I mean that's the minimal of the training budget would be is $1,000. I mean, come on. This, if they're not gonna give you less than that, they're just a bunch of cheapskates. Yeah. So, uh, moving on. I digress. So basically, there's multiple copies of the repository being used by the development team. This allows for the ability for developers to work on the entirety of the code base and merge their changes with their fellow team members' changes. So that's basically Git in a nutshell. Some well-known. So the thing about Git is you don't really have a central repository per se, but you do have like a source of truth. Like you do have a remote repository that all the developers interact with, and it provides a way of syncing. And there are some sites, like public sites, that allow you to do that. A well-known site is GitHub. Uh, Git and GitHub are actually totally different. Just a trivia. But that's a well-known social media site for developers, and it's been around for quite some time. There are others like Bitbucket. Bitbucket is also another remote repository site. GitLab is the new kid on the block. They do this same thing but offer different services, such as like continuous integration. So yeah, that's basically Git in a nutshell and how it works. But you're probably thinking, if you're a newer, it's like, okay, I still don't understand. What do you mean by these central repositories? What the hell is a repository? Or syncing? You mean I gotta sync my code changes with other developer code changes? How the heck do you do that? What kind of choreograph do you have to pull off to do that? Well, don't worry, I'm going to casually explain it. um, yeah, so basically what I'm going to do, basically I'm still explaining it, but I wanted to explain it in a way that it matches an analogy in life. I wanted to compare it to something in your life that is actually quite similar to version control. And I figure if I explain it that way, it's a lot easier to understand. And when this live stream is over and you want to learn more about it, it's not going to be a complete mystery. So first things first, you want to make sure you have Git installed on your system. Just because maybe you want to follow along, because I will do some code examples and just examples of on the command line interface. Uh, just to give you a kind of visual. I won't go too deep into the command line interface because there's a lot with Git, and some of these commands are, I could spend an entire live stream talking about how they work. So I want to keep it as simple as possible, but I want you to at least walk away having at least a basic understanding how Git works and what to expect when you do go in the workplace. If you go into the interview and they ask you, have you ever worked with a version control system, you can at least say, well, I did work with Git. I have a little bit of understanding, and you can talk about all the different workflows that dev shops would typically use. So, without further ado, you want to make sure you have Git installed first. If you are an Apple user, you're in luck because, from my understanding, Apple users already have Git, so you guys are lucky. I'm jealous of Apple users. And it's really easy to do. And in fact, I think if you type Git and then dash dash version and the command line like this, and let me bring up my Visual Studio Code up. It won't work on mine because I'm obviously using Windows. Hopefully, you guys can see that. So, if you are in a Mac and you were using VS Code or your terminal, um, oh, hold on, I gotta switch over to PowerShell or Bash is fine. You can. So, I actually switch between PowerShell and Bash. Sometimes I need Bash to do certain things, and then sometimes I prefer doing stuff in PowerShell. I'm weird like that. So, let's see, PowerShell. Obviously, a terminal is gonna look a lot different. Well, that's not cool. Oh, here we go, PowerShell. And nope. I swear, I know what I'm doing, guys. There we go. And I want to add another one. PowerShell. There we go. So this obviously your terminal and on your Mac system is going to look a little different, but if you just simply type in Git version, Mac will actually go through a process of installing Git. But if you prefer using an installer with Git, what you can do is you can basically you can download the installer uh, build for your Mac and basically install it that way. But it really Mac it's already there in your operating system, which is cool. But this right here wouldn't look the same because it's PowerShell. You would actually see something similar to Bash, like we saw earlier. Yeah. So you can install it that way if you have a Mac, or if you're Windows, you do need an installer. Actually, hold on one moment, guys. It's getting a little darky here. Ugh. Sorry about that. It was getting a little dark and a little dull, so I put the lights on. So if you have Windows, you would actually get the installer for Windows. I'm sure there's a way you can do it on PowerShell, but it's a lot easier. Just download the installer. I know some of you Linux folks don't like that. Let's see. Let me switch Windows here. Shut off VS Code, window capture. So you essentially go here and then click on download, and then you want to download the installer. And once it downloads, I'm just going to take a little bit because I'm streaming as well. And then it'll have a splash screen. You might have to use administrative rights for that. There we go. So you'll run into something like this. Now, I already have Git on my machine, so I'm not going to go through the installer process, but this is typically what you would do if you needed to install it on Windows. Linux is actually a little bit more straightforward. It's you don't typically don't have Git on your Linux operating system as is. You do have to install it. One way you can do it if you have a Debian based OS system or Ubuntu. I know a lot of folks that are into Linux they use Ubuntu. You would use your apt-get to install Git. You would use something like this right here. But that would be the way you install Git. And to move on to more like, okay, all right, okay, Dan, tell me how Git relates to real life. Well, Git is basically a version control system. It's a way to keep track of changes in your software, and it's history based. So your version control system would keep a timeline of all the changes you've done to your code base. And that version control system needs to be able to organize those changes on your code base in such a way that it keeps track of who did what, when, and then what type of iteration or like a series of iterations did it come from, right? But that doesn't make any sense. Obviously, software development is very abstract. So we typically use more, we still stay abstract. And we typically use a real life example of how a version control system would be used with your software code base. I'd like to use the analogy of a mother, or let's say you have a child or a favorite pet, and you want to keep, you want to basically capture the memories of with that child or favorite pet. So how do you do that? Well, obviously you take a photo of that particular experience, and you typically call that photo a snapshot. That snapshot just basically says, "Oh, this is essentially my child at this time and doing this thing, and I want to keep this memory in forever." You want to do the same thing with software development. You obviously want to have a memory of the things you did, because if you didn't, you would go insane. Um, so in Git, these snapshots are typically called commits because we're committing a change to the code base, right? Now, in Git, compared to other version control systems, is a little different when it comes to what our commits are. A commit is essentially a snapshot. It's not a diff. It basically in Git, your commit is this set of changes that are let's see. Is using the Windows Explorer integration a good thing? Part of installation options. Um, yes, because with the Windows Explorer integration, you can open up Git Bash. Now, Windows 10 does have a Git or a Bash terminal that you can use. Uh, I highly suggest doing it. It's nice because I'm more of working with the command line interface. I know some folks out there prefer the GUI. There are GUI interfaces that you can use, like SourceTree, but you're not going to be as powerful on those GUIs compared to being on a command line interface. You're going to have a lot of power user features. You're going to be a lot more empowered using the command line interface compared to the GUIs. Because the problem with GUIs is, yeah, it does visualize your branches, because it is hard to think about your repository and all the different branches and how they merge and all the different commits associated with those branches. It's hard to visualize that, and those GUIs do provide that as visual assistance. But the problem is, after a while, you're going to run into problems where if you want to do a certain thing, it's you're not going to be able to do it with the GUI because the GUI just doesn't simply allow it. Ran into a lot of problems in my short career using like SourceTree, using SourceTree, and at the end of the day, I always go straight back to the command line interface. So, yeah. If you are a VS Code user or Visual Studio user, they do have plugins you can use that for your repository, and it's awesome. More so with VS Code, because it visually tracks it in a way that makes sense. I hope that kind of gives a clearer picture. Yeah. So the VS Code is good because if you make a change in your project, it actually shows you all the changes that you did, and then it does have buttons that you can click on to basically stage your code or commit your code, or what branch it's supposed to go to and all that good stuff. But we'll learn more. I know some folks don't understand what branching is or don't understand what a commit is yet. I know I went over a little bit. And we're eventually going to go over that. But VS Code does offer Git Lens, and Git Lens is great because you can compare different branches and what the changes that you've done between your commits or your branches or whatever. So, yeah. Excuse me. So let me switch back to VS Code because we're going to be writing some code really soon. Okay. So going back on the analogy, so think of a version control system as a series of albums. And let's say you had a favorite pet or fur baby or an actual child that you want. Well, of course, your child is your favorite child. If they're not, then well, and there's some problems there. Um, you want to capture an experience, and you want to keep a chronological order of that experience. So you take snapshots of your child as they grow up, so you can keep that chronological order. So version control systems are very much the same way. Git is very much the same way. You're just taking snapshots of your code base, and the certain changes. So with that being said, let me show you. Like just a couple commands associated with that, right? So I'm in an empty project. I don't have anything in here. This is my root project. And let's just build, photo album would be great, and we had some photos, but the thing is, you don't want to see me as a kid. I'm nothing to look at as a baby. So I'm just going to use something simple as like a web project. Now, first things first, we need to make sure that we initialize our Git repository. So to do that, you would first start off with your Git command. So Git, and then to start the project, you want to do init. And what this does is it actually creates a directory inside your root directory called .git. Now, here's the thing about .git, and this is particularly for Windows users. Dot directories that have a name that start with a dot are typically not immediately seen in your file explorer. So there's a way you can turn those on so you can actually see them, but if you normally by default you can't see them. I may be getting a little ahead of myself here, but let me show you. Let me show you what you typically see in Windows. So git init will initialize your .git repository, right? So git init, and you'll notice here it says initialize empty git repository and my relative path right here, right? So you're not going to see it here, but if we go into our file explorer, and I'll just copy this right here. Nothing in there. Okay, that makes sense. Like I said, you're not going to see it. However, if you go here and go to hidden items, you'll notice that the .git, you can finally see it, right? So just a reminder, if you do the git initiate or init and you're trying to find that any files or directories that begin with a dot, just make sure that when you're in File Explorer, you just click on Show Hidden Files and you'll see it. So Git will actually generate a directory. Oh shoot, I didn't mean to do that. Sorry, folks. So Git will actually initialize a directory called .git, and what .git does is it basically saves all your snapshots and all your organization of those snapshots, like your branches, your tags, your whatever, right? So if we explored into it, you'll see that there's different files that handle this. We're not going to go too deep into this because it kind of deviates to what we're trying to accomplish today. But just to give you a kind of a snippet or a taste of what it does, the .git directory basically holds your snapshots as objects, and they also hold references to those objects. But that's it. I don't want to get far too into it because that could basically take up an entire live stream. So now we initialize Git on our directory, and now it's okay. We're creating a web project. So every web project typically starts with an index.html, right? We got to have HTML so we can show stuff to the user when they're on the browser and navigate to our site. So we want to create that. I typically just PowerShell's got a really verbose way of creating files. I don't really like to use it. So we're going to say index.html. We've got our HTML document. We're going to provide it with shoot, doc. Can't type today. Normally, Emmett is working for me. There we go. So we got an HTML document here. So, all right. So what Git does is it keeps track of changes from your last from your head. So what is a head? So a head is basically it is your snapshot that you're currently it's your working copy of your repository of that particular moment. So think of it like you have your phone out, right? You have your phone, you're about to take a picture. That's basically what the head is. It's the image that you're trying to capture that the camera sees. That is basically what the head is. And then anything past the head is basically your commits. So right now we're currently at the head of our repository. So okay, let's put some stuff in here. Let's actually put some content, right? So let's say I don't know. Let's put a H1, and then this H1 is we'll call it photo album. All right, great. Got a title. And we want to make sure we change this too. So we'll call it our photo album. All right. Now, we want to eventually style this, but we don't want to put our styles in our HTML document, right? So let's create another file. Let's call it styles.css. All right, and then I don't know, we'll put some resets on here. Let's just say HTML all, and we'll say something like border box. Or is it box sizing? Border box. We just want to make it easy for us while we're styling, and margin 0, padding 0, right? We just want to put some resets, reset defaults, right? Okay, cool. So we got two files, and then we want to make sure we include our CSS, and we're going to call this style.css. Perfect. All right, cool. All right, so okay, let's say we want to do our first commit. We did some work here. There's enough work here that it was safe to say there's significant changes. So okay, well, you don't necessarily just commit. So what I mean by that is you want to Git will actually ask you what files you want to commit to your code, right? So the way you do that is you actually do a git status. And what git status does is it actually shows you all your files, either that are untracked or that you've included in the cache for your code repository. These are the files that you track. It will tell you what branch you're on. Currently, we're on master. Think of master as being production. This is your source of truth. This is the branch that everyone syncs to. Yeah. So we have two files that are currently being untracked. This is files that Git doesn't really care about until we tell it to care about it, right? And what we want to do is we want to make sure we tell Git to go ahead and to track these files. So you could do that two ways. You can do each individual file, so do a git add and then index.html. And what that'll do is it will tell Git to go ahead and track this file. So as you can see, Git is pretty smart. It knows when a file is new. It knows when a file gets deleted. So the deleted files are passed into staging. It knows when a file is modified. And yeah, basically, this step is basically you're telling Git to stage files for the commit. Because sometimes, let's say, going back to the photo album analogy, let's say you went on vacation with your kid and you took a bunch of pictures with the family. And of course, some of the pictures are great, they're memorable, but there's also some pictures that are like, who cares? I think Barbara was butt dialed her phone, actually took a picture of her butt. I mean, we don't care about that. Or like, oh, we took a picture at Niagara Falls, but we also took a bunch of pictures over in Ann Arbor, and I don't know where the geographical differences between Niagara Falls and Ann Arbor, but work with me. Basically, it's like, well, I don't want to include that into the commits. I don't want to include that in that like day. I actually wanted to include it based on categorical. So what I'm getting to is you can actually just choose what files that you want to include on the snapshot. So if we committed these changes now, the only thing that would be committed would be index.html. So we actually want to include them both. And let's say all the files that are either untracked or have changes or unstaged, you want to stage them all, you can say something like this, git add dot. And now will tell Git to basically include all the files that have changed or are being untracked. And as you can see, voila, perfect. Okay, cool. All right. So John says, is it CD to move to a folder? Is there a way to paste the directory into the command prompt? What folder do you use index.html in? This? Um, and then probably, you got a lot of questions. uh, so let me start off with CD. So CD stands for changing directories. So let's say this is both for bash or shell or any type of command line interface. These are basic file transversals. So let's say cd stands for change directory. I don't want to be in casual git. You would essentially, let's say, here, let me make it easier. Let's say I'm starting from my root C drive. In PowerShell, you can essentially change it to any directory from where you're at, right? So if I'm in C, I have a couple of files here. I want to go into users, but you can use file paths. So you don't have to transverse one directory at a time. You can actually say something like this, right? You can say something like my user, right? You can say something like this and it'll take me straight there. And then you could do CD and then temp, like I put this in my temp projects folder. Oh, well, projects, and then temp projects, and then casual there, and it'll take me right back there. Now, let's say you wanted to um, go up a directory, so you want to go up to the parent directory. You can say something like this. You can do a dot dot, and it'll just move it up one level. So if you do this, we'll take us right back to the temp projects 2020. And then let's say oh crap, I am really deep in this. I need to go up a couple levels. You can say something like this. You can say dot dot, and then remember in Windows it's backslash. If you're doing your file address, it's always backslashes. Linux is different. It's front slashes. So just tidbit there with Windows. If you say something like this, it'll take you back to your user DS321, which is my user. So we don't want to do that. We want to actually go back into the projects. I'm goofing up here. 2020 casual. There we go. Cool. So that's just basically a short tutorial on how to change directories. Right. Yeah. So the Git window uses Bash because it's Linux. It uses front slashes on the file paths. So Windows, just remember Windows does backslashes. Windows use backslashes. Linux use front slashes. Or Windows and Mac use front slashes. Yeah. And then also, is there a way to paste the directory in the command prompt? Yes. The command prompt, I think PowerShell and command prompt are different. So if you wanted to paste in a file path, say for instance, I wanted to, I don't know, let's say I want to take this file path right here. I believe if you right click on PowerShell, it would actually just automatically paste it for you. Linux is different. Linux actually has a specific key combination to do. It's really weird. But you have to remember, Linux is actually a command. It's a terminal operating system at heart. So you're operating out of the terminal most of the time. You're not like Windows where you have a GUI interface. So command prompt, if you just right click, you would automatically put that there. I don't believe, yeah, Control V works. In fact, we can actually test this on here. Well, I can't show that to you because OBS likes to look at Windows. So if you try to PowerShell, it should work too. And then to answer your other question, well, the problem was the new path was Windows style path, but the bash window requires Unix path. Yeah. Well, file path was Windows style path, but the bash window requires Unix path. I think you're talking about the way the file structure is set up, because in Bash, it's to get Bash to work in Windows, you have to do a lot of gymnastics with the way the file structures are set up in Windows. And it's even weirder with WSL, with the Linux, what do you call it? WSL2, where you still have separate file systems, and WSL is actually a virtual instance of Linux. And if you want to communicate with Windows, it gets a little weird. Yeah, so I wanted to copy the path from Windows Explorer. Yeah, I don't think Bash should get upset if you do put a Windows. I think that get Bash will automatic. Well, I have to foot around with it, but yeah, I think it would still let you do it. But to answer your question regarding .git, no. .git is the Git repository itself. So it's where all your snapshots are saved. It's not the actual source code. So remember, .git is your commits, but the root project itself is your source code. So you wouldn't be putting any files inside .git. The git command will actually do that stuff for you with the .git directory. Yeah. Yeah, we're basically, just think of the .git folder. There's a reason why it's hidden. It's because it operates in the background. We don't want to mess around with that because that has our history, and any changes to that, you're going to screw up your local repository. You don't want to do that. Yes, yep, yeah, it is important. A lot of people they get confused by that. In Linux, that's not the case. In fact, well, no, Linux you still have to do /all, but I think it depends on your user profile. Yeah, cool. All right, so moving on. Ooh, my neck, man. Whew. Gets really tight sometimes. We need to go back, but I believe we can still go here. So we got two files. They're new files. They're being tracked right now. Now we're ready to do our first commit. So to do a commit, you type in git commit, pretty straightforward, but there's an attribute you have to include. An attribute. So you have to include -m. What -m means is .message. You have to always include a message with your commit. If you don't, basically Git will force you to put a message in. You don't want to do that, especially if you're not familiar with Nano or any of the editors that come with Git. It gets really confusing. So always make sure to put a -m, and then you're going to use quotation marks just like in a string, and you're just going to write a commit message. What should be in a Git commit message? Well, it depends. At work, we typically just type in why we made the changes that we did. It's not necessary to tell us what you changed because Git is already describing that for you. So here it says we're just going to say first commit because we just put in our initial files, right? So once we commit, you do get an output, and it basically gives you the branch that you put the commit on, the hash. So commits are actually separated; they're uniquely identified by hashes. I don't know the type of hashes that they are, but the hashes themselves are either their actual full length, or they could be their shorthand hashes. We have our get message. This tells us how many files have been changed. It even goes as far as insertions as well. And this tells you basically the files that you changed or added or deleted, right? Let's see. Okay. Great. We got a commit. So what does this mean? We have a snapshot or like a photo of our code that is sitting in our Git repository and is sitting locally there. So we have basically created a timeline for our local repository instance. Cool. This is awesome. All right. So we got our first commit down. And obviously, as you make more changes, you'll create more untracked and unstaged files, and then we'll have to eventually commit those. All right, cool. Oh, I did not want to do that. All right. So what's next? Well, oh, sorry, almost forgot. So let's say, Dan, that's great. Yeah, I can make these commits, but maybe I want to, that's the whole point of these commits is to keep a moment of time of your code so you can check back, right? So if you want to look at a history of commits on your branch, what you do is you type in git log. What this does is it basically gives you a history of all your commits on your branches, essentially. So here we have our first commit. This is the long hash that is typically identified, and it gives you the author, tells you who did this commit, what day, or a date, the message, and that's about it. Now, these could get so long they could be very unmanaged. So if you wanted to get a shorthand version of the log, you can say something like this. I think it's one line. And it will just give you one line. It just gives you a shorthand hash, the branch that the commit was put on, and the commit message. All right. It asked me to identify myself. Well, if you are installing Git, most of the time it does require administrative. It does require administrative rights to install. So is it like asking yes or no if you want to install it, and it's like it needs administrative abilities to install Git? Ooh. Yeah, you could do something like that. Yeah, it's probably you do want to identify yourself because it needs a way of it needs a way to know who did the commit. So sorry about that. I should have included that. But yeah, and that actually plays into the remote. That plays into the remote repositories as well as you start pushing out your commits and your changes out to the remote repos too. Um, yeah. So that should get you started with yeah. It should get you started with moving forward with Git. Um, all right, cool. All right, you do that commit. And it doesn't necessarily have to be a web project. It could be as simple as text files, right? You can make changes to text files, and you can see how Git works with keeping track of changes and how commits work, right? So, Man, throat's getting dry. All right. I'm gonna take like a 2 minute break. I'm gonna get some water because my throat's getting really dry. And we can pick up on essentially branches. Yeah, we'll talk about branches and how you can have separate timelines and then merging those timelines back together. All right, I'll be right back, folks. Okay, I'm back. All right, I'm gonna take a sip. Much better. All right. Okay. So moving on. Um, Now going back onto the photo album analogy. So most parents or most parents of children or fur babies, they like to keep track of their moments in a chronological order. But sometimes they don't always keep it in one album because people like to categorize things. For instance, baby books, pictures of your first day of school. I know some parents like to take pictures and have like a mini album of as your first day of school. Kindergarten graduation, prom, etc. Stuff like that. You don't always have all your photos in one album, right? You typically separate those photos out into different albums and different depending on your period of your life, right? Because you're not always going to carry a huge album with you to put your pictures in. You're going to create, one album just for a particular uh, phase of your life. So Git is no different because in Git, sometimes when you're doing changes to your code, you may be you want to make changes to your code base, but you don't want to take the risk of breaking something that's already in the code, or you want to take less risk as to messing up your code base essentially. And the ways you do that is instead of creating commits on one branch, you can create separate, or maybe you want to create a whole new feature, and that feature you just want to focus on that feature and you don't want it to affect anything else that you're coding, maybe someone else is coding on the main branch. So you create a branch, and that branch could be a copy of the master branch, and essentially you can do all your changes there and then eventually merge those changes back into master in a coordinated fashion, right? So how do you do that? what's the process of creating a branch, and when do you create a branch? So if we go back to our code, let's say that we wanted to, I don't know, we wanted to create a list, right? We want to create a list feature, but we imagine this is actually a bigger HTML document. And that HTML document, there's some things in there I really don't want to mess around with, right? I might have another team member that may be working on that, and I really prefer just to keep it separate. So to do that, I want to create a branch, it would say something like get branch, so that this designates that we're working with branches. And if you wanted to create a whole new branch, you can essentially just create the new name of your branch. So we could say something like new branch. So what that doesn't look like anything happened, but if you check out the list of branches that we have, you'll notice that we have our master branch, which was our original branch, and we have a new branch called new branch. So by doing that, it actually creates an entirely new branch for your repository. Okay, all right. Well, I don't. Let's say you make a mistake, and it's like, I don't want to call it new branch. I want to call it something different. So that's actually really easy to do. You can say something like get branch, and then message, or -m, and then you can take your old branch name that's currently in your repository and can change it to something different. You can say something like, I don't know, unordered list, because we're going to create a list in our code. So now if we go back to branch, now that the new branch has a new name called unordered list. All right. So, okay, great. So does this mean I am in this branch now since I created it? How do I move over to that? How do I start working off of that timeline, of that specific timeline branch? So if you wanted to go to that branch, you would simply go to get, and then there's a keyword called checkout. All right, I'm taking another sip because my mouth is dry. Okay. So you could do a get checkout, and then you would go to the name of your new branch, which is unordered list. And as you can see, the output is says switch to branch unordered list. Cool. So what does this mean? It means that we're currently on the unordered list branch, and any commits that we commit will be committed to this branch. Cool. All right. So this means that master branch won't be touched for now until we merge our changes in. Cool. All right. Well, let's go ahead and put our changes in then. Create an unordered list. Unordered list. We're going to create a list items of 5. And I think there's a way you can, let's just say, I don't know, pictures. I think you'd say something like that. It will, shoot. Yeah, bear with me, folks. I'm trying to get my bearings with Emmett. There we go. There we go. So we have a list of pictures, right? And in fact, we could probably say something like list. And each of those lists, we have an image. I don't know. Let's just get a source set. Oh no. Yeah, that's definitely not what we wanted to do. Nope. Shoot. Well, we have a list, right? So we'll just say pictures, because the whole intents of prince the, the main concern is how Git works here, right? Sometimes I get cops. All right, we got a list. We got a list now. So now if we go to Git status, we can see that we modify index.html and we made our changes there. However, if we check out master, so Git status. Oh shoot. Yeah. So here's the thing. If you do have modified, and you'll probably notice, Git checkout, switch to master. Hold on. Git status. We are currently on branch master. Oh, okay. So here. Sometimes if you have unstaged changes, Git will sometimes, and it didn't do it this time, but sometimes it will prevent you from checking out a different branch, because those changes aren't being tracked and you got to put those changes somewhere, right? So let's do this. It's always a good idea, and this is actually really handy. So Git status. Uh, you want to basically cache those changes temporarily until you're ready to essentially commit those changes, or at least stage them. To do that, you would have this thing called stash, and then you just simply say git stash, and what that does is it caches it in memory of all your changes. So now you'll notice that there are no changes anymore, because we basically cache those changes temporarily, right? So we don't want to do that. We actually want to, because you already know that, okay, unordered list, basically branch already has these changes. So cool. All right. So git stash pop. So git stash spot pop basically moves those cache changes moves the cache changes over to your branch and makes them unstaged. Voila. There we go. Okay. All right. So we wanted to commit. Well, add first. So we're going to add all. And then we're going to commit these changes. And we're going to say something like need pictures. Added pictures meets, I don't know. Added pictures meets, sorry, I thought thought my camera was going bad. It was blurring. Added pictures meets, I don't know, requirements. Something is, why did we make that change? Right, so we committed that. We do a git log. Now, if you look here, notice that the git log, it does. I said that when you're on the git log, it basically tracks all the changes on that branch. Not necessarily. It tracks all commits, but it does tell you what branch you committed it to. And if you go to git checkout master, you'll notice that git master doesn't have that, because we don't have that commit on master. That commit sits on unordered list, right? So let's go back to unordered list. So you can see the changes now. Okay. Some other cool stuff about branches. You don't always have to have a branch. Maybe you don't no longer need that branch anymore. You can say something like git branch -d. The capital D stands for deleting a branch, and then the name of your branch you want to delete. Right? We don't want to do that though. Also, sometimes you can't see all the branches, because not all the branches may be local to it's not local to your local repository. It may be just sitting on the remote. If you want to see all of those, including both your local and your remote branches. You could say something like this. You could say branch.a. Obviously, we're not going to see any remote branches just because we don't have a remote repository set up just yet. But if you did and you had branches that you haven't pulled down yet to your local repository, you'll actually see it right here, and it'll actually show up in red just to designate that they're not there. That dash A stands for all. And if you wanted to check out that branch, I believe it's as simple as it's git check out and then whatever your remote branch is. So remote dash branch, and the name of your branch. Cool. So it says, seems weird. I had to do git at all when newly an unordered list branch. Index should have already been in that branch because we copied master. So what was the point of doing git add when an unordered list? Let me read that again. So it seems weird. I had to do a git at all when newly branch should already have been in that branch because we copied master. Yes, it would. You basically, if you're doing a new branch from the branch you're checked out, that will essentially copy it. And it says should already have been in the branch because we copied master. So what was the point of doing git add when you added that code there? That code, and I may be misunderstanding. We put new code in index.html, so that's a change. That changes the file. So when you look at the add, it's not going to show up as untracked. It's going to show up as unstaged because you are tracking that file, but because there's changes there, that it automatically unstages the file. It's like, okay, you have some changes, but you haven't staged them yet before the commit. And then once you stage them, then you can continue forth to commit. So are you saying that you didn't see the index HTML there when you created a new branch? I guess it's kind of hard to tell. Sometimes I have to look to see why something didn't work the way it did. So okay, so you got an error when you tried to commit. Um, okay, so git commit -m remove br added unordered on branch unordered list changes not staged for commit. Yeah, so you initially got it. So obviously you did modify the index.html, so you are going to see that as unstaged. So I did a git at all. Okay, then I could commit. Right. Right. So so when you make a change in that file, right? This is what it's telling us. We're on branch unordered list. You you well, first you try to commit, but obviously we can't commit unless we stage files. And here file update to be committed, and then modify. So you made a modification to that file, and hence why we see it as as basically stage. But here, so add doesn't mean add file; it means add change. Add is weird. So add means you're adding files to stage, and those files could be in different states. So git add is what does staging. Yes, so it adds your change or modified or a file that differs from the last commit. It's adding it to staging. So files are either staged or unstaged. Unstaged, they're not ready. You have not approved it to go into the commit. Stage means, okay, I choose this file to go into the commit, and then once you have all the files once you have all the files staged, and then you're ready to commit. Those are the files that will get added to the commit. So don't think it so much as you're right. So don't think of it as adding a file. Think of it as adding a change. Because a change could be anything. It could be modified, it could be a new file, it could be a deleted file. So deleted files can actually get included into staging. But the key thing here is, what is the difference? Yeah, what is the difference between what you have currently in your head, which is, think of it like the camera, you're about to take the picture and you got the visuals in the camera on the screen, compared to the last photo that you took, right? That's how the staging works, or the get status works. It looks at the differences between your last commit and then your current head. So yeah, it took me a while to understand too, because I was still thinking about files. I wasn't actually necessarily thinking about changes. Because most people, when they think, especially newbies, they think, oh, I do my changes. They think it's like a save feature on your editor where you save it. Okay, we move on to, I just committed it. No. You get checks, ask you what files you want to put to the commit, and you do that by staging those files, and then you make your commit, or essentially like saving on your text editor. Yeah. All right. Cool. All right. There's some other commands I wanted to show you. So things you can do. Okay. So let's say, all right, we did some changes. Let's add one more thing here. Let's add I don't know, just put like a P tag here, or add some content. Let's add one more thing. I know it's on a word list, but it'll be like a description. We'll do a get status, double check to see, oh, this says nothing to commit. And that's probably because I didn't save anything. There we go. So as you can see, we have our modified index HTML. Now I want you to take a look here. And not so much this, because we already know what this does, but wait a minute, Dan, I thought you said get checkout, check out branches. Are you on crack? No. Actually, it's there's get checkout can do multiple things. One of the things they can do is, if you have a file that is currently unstaged and you made a change to it but realized you didn't want to make a change to it, it's like, oh, I screwed up, I need to restart, I need to start fresh. Well, don't go back and try to go back to all the changes you did on the file. Git makes it really easy where you could just essentially reset back to where the last commit was. So the get checkout here with the dash just simply says, hey, just discard any changes I did to this working file, this file in the working directory. So let's say I didn't want to do that. What was I thinking? Why wouldn't I want to include it in that branch? I could say something like get checkout index.html, and then as you can see, the paragraph tag is gone, and we basically started out from the last commit that we did. And then if you look in get status, nothing to commit because there was no changes. Your head and your last commit are completely identical. So cool. All right, how you guys doing? Am I losing you guys, or anything that you didn't quite understand, or something that didn't quite make any sense? Are you guys doing all right so far? I know I said it casually explained, but I know there was probably a little bit more of the technical side than there is just the kind of the theory side. No, that's all good. Questions are good. If you're not asking questions, then I'm not doing a very good job. Yeah, there's one thing I learned is if someone's asking a lot of questions when you're teaching something, it typically means that they're engaged and nothing is flying by their head. They're actually very interested in understanding. So it's good that you're asking questions. Plus, it means that people are listening. uh, and yeah, people are listening, and I'm keeping people engaged. So that's what's important. Oh no, what happened to my? What happened here? Oh, it's probably because if I minimize it, I can't minimize that. Yeah. Okay, cool. So, all right. Now we done our changes. Eventually, our branch isn't going to sit by itself. It's rare for a branch to basically be off on its own, diverge from your production branch, your master branch. Eventually, that gets merged back in. So, how do you do that? How do you merge this? How do you merge your code over to master? So the way you do that on your local repository is you do git checkout. So we're going to check out master because that's where we want to merge our code. You could do it this way, but you can also do it. You can actually say something like unordered list, and then the branch that we want to merge into is master, like this. Not something we can merge. Okay. Maybe because I spelt it wrong. Because I am a terrible speller, if you haven't noticed. Oop. So, unordered list, master. Ah, there. So this is what we did. We did a git merge, and we took the branch that we want to merge to, or we want to take the branch that we're merging into the branch that we want to merge to. So unordered list is being merged into master, and that did give us some output here. So this is our hashes. And when you do a merge, and you'll notice in the git log, oop, um, you'll notice that, well, when you do a merge, you typically, the merges themselves are commits. So if you have a merge, essentially you're going to create a commit based off that merge. Here you can tell that you have your commit. This commit, we never did this commit in master, right? We basically did a merge from unordered list to master. Hence added pictures to meet requirements. This was never here in master until we merged. So what we did is we essentially merged the timeline of our unordered list into master, and we basically sat that on top of the latest commit that we had for master. This is pretty straightforward, but it does get complicated when you start working with bigger code bases. And the reason being is sometimes you don't want that because you could have like a boatload of commits on a branch, and you put on top of your master, it could be really hard to track. So they have this thing called rebasing against merging. So there's merging and rebasing. Merging, you're basically just squashing everything together. Rebasing basically takes all the commits of that one branch and makes it into one. It's like an abridged version of that branch and attacks it onto master. So it seems like it's a one seamless timeline with master. They all both have advantages and disadvantages. In the workplace, we typically just merge our code because history is everything. Uh, you know, it's, you know, In most big corporate offices, bureaucracy is rampant, and they want to have a paper trail. And essentially, merging code is basically like a paper trail to them. You want to have a history. You don't want to lose any commits whatsoever. They're precious. If you lose them, then bad things happen, like audits. So yeah, basically when you do a merge, you're removing all those commits from that branch and merging into the branch that's supposed to be merged into, and then it basically is just a tack on. As you can see here, I hope that makes sense because it, I felt like I could explain that a lot better. So, but if we check here and do git log, um, yeah, well, sorry, it doesn't really matter because git log is based off of it's the history of the repository or the commits. But yeah, as you can see, you have master and unordered list. So cool. Underscore having trouble merging. Is this what you did? Get merge unordered list to master merge unordered. Not something we can merge. Well, it depends. If you do a git branch like this, what branches do you see? You might have a typo there, unless that's the name of the branch that you have. Yeah. So it looks like, well, I mean, it could be, but if this is the two branches that you have, and then you're using this is the branch we're merging, and master we're merging into, then you may want to switch this with this. I think it may have just had a typo. Or did you, um, well, yeah, just try it again. Try it again with this branch right here as your first one. So you have your list of branches, right? You have master, which has the asterisk, which is the current branch that you're on, and then you have your second branch, the unordered list. I think what happened was when you did the get merged, you had a typo in your unordered list. Right. So there's two ways you can do it. You could sit on the branch that you want to merge into, and you can say get merge, and then the branch that you want to merge to, or you're going to use to merge to. And then you can say, okay, you don't necessarily have to do that. You could say get merge the branch that you're merging, and then the branch you want to merge to. I know it's a little confusing. So essentially, master, you want to take all those commits from unordered list, and then move them over and combine them with the timeline with master. I No, I don't think you would need a dash m. You actually had the right syntax there, the merge. I think what happened was you have yes, yes. That's well. Um, uh, this is the so this time you have the correct branch, the unordered list to master. So that means that we're taking the unordered list and we're merging it to master. I think what happened was you just had that typo, and then because of the typo, Git was like, I don't know what this branch is. I don't see it in our list of branches. Dash M. Let's see what dash M is. That actually sounds interesting. And also, Git has a really good help documentation. You can actually get through the command line. So if you do something like git merge and then dash dash help, or I think it's dash H, it will actually give you really good information. So let's see. Here we go. Dash M is message. So you can include a message on to the merge. That typically requires like a string, and that string would basically say, hey, this is the merge, and this is the reason why we're doing the merge. We also have a couple other attributes that you can include as well. Yep. Yep. Cool. Yeah, awesome. Progress. Yeah, but guys, if you ever get stuck or you want to learn more, like all the things you could do with Git, they had a really great documentation out of the command line with their help pages. As you can see here, there's a series of attributes that you can use, and then also gives you the usage too, like what's the proper syntax. Yeah, yeah, good. Oh, sorry guys. Cool. All right. Well, I want to keep moving on. Yeah. Again, with rebasing and merging, I'm not going to get too far into that just because it could get really complex. And some things you're going to pick up a lot quicker in the workplace, that it will make more sense to use rebasing over merging. So, yeah. Okay. Great. So now I think we covered enough with the branches to give you a good idea how branches work. And it's going to make a lot more sense with branches as we get more into the remote, like having remote repositories. So actually, that's a great lead in. And just going back on an analogy of, photo albums and, taking pictures of memories, experiences. We all know that our pets and our kids don't live in a vacuum. Obviously, we can potentially have extended family. Let's see. Speaking of merging, command line can be good for commits, switching branches, but mergens, I think a GUI would be a place to do that, right? Personally, in my opinion, no. And here's why. GUIs, sure, they give you a visual aid as to all your different branches and seeing them merging into each other. However, you can actually be more empowered in your actual merging from the command line interface. And there's also a lot of Git hooks out there, which are basically kind of like they're kind of like custom coding for Gits that you can, if you have like a certain trigger and you hit it, it will do a certain thing. And I'm actually going to get into it later on in the live stream where I talk about Git workflow, where Git workflow can talk more as to, it can actually automate a lot of the merging process. It's really cool. A GUI, again, this is just my personal opinion. I just don't think they're very useful because the CLI can do can do just as much, if not more. And I feel as though GUIs can get you in trouble because even the visual aids can be misleading at times. But again, that's just my opinion. I wouldn't stop you. I wouldn't stop anybody from using it if it makes them more productive. Because at the end of the day, it's what makes you most productive, right? Um, Yeah. So going back on the actual, going back on the remote repositories, you know, we have extended families. Obviously, our extended family is going to have their own photo albums, right? And they may want to have pictures that we may want to include pictures in their albums. Um, we may want to include pictures for their albums, and then we might have pictures that they want to include in their albums as well. And it, this is where it goes back to Git being a distributed version control system, because everyone has a copy of their own. Everyone has their copy of their own repository, but it doesn't necessarily mean that it's synced. Git allows you that ability to make it easy to sync amongst each other. So how do you do that? I mean, how exactly do you do that? And this is where distributed. I wouldn't call it decentralized, because a remote repository. Let's be real. A remote repository is centralized. Everyone is syncing based off that remote repository, but not in the sense that that's like the only. It's not a centralized version control system where if John or sorry, man. John, so let's say John is working on index.html. A centralized repository would say, oh, well, John checked that out. That's locked until John finishes up with his code changes. You'll have to wait. With a distributed version control system like Git, I can work on index.html at the same time John does. However, Git will handle a lot of the synchronization between the changes that John and I do to the index.html. So how does Git end up doing that, and what commands do we use to create that synchronization, right? So to do that, essentially, we have to have a remote repository. We have to have some sort of source of truth where there's like one endpoint that we both can go to. And that's where I was talking about, like with GitHub and GitLab and Bitbucket and all that good stuff. Essentially, you would set up a remote repository and then use that to sync. So I'm actually going to do that. Let me switch over to. Oh, I'm sorry, guys. Here we go. Let me switch over to my window capture. And I want to shut off VS Code for just a moment. And let's check out GitHub. So GitHub. Cool. We're in GitHub. So we have to set up a remote repository if, say, I wanted to have others work with me on my code base, right? So obviously, all these different remote repositories will have a different path, but they all achieve the same goal, which is basically a remote repo. So I'm going to call this casual git, right? That's the name of a repository. And I want to make it public because obviously I want others to work on it. You can make it private, but we're not making money off of this, so we'll create a repository. So this will create a remote repository. And GitHub's really great. They actually give you instructions to set it up. Like for instance, creating the remote or URL so you can communicate with it and to pull it out or push your code changes, right? Yeah, my throat's getting dry again. Let me get another drink. Okay. So as you can see, we have it gives us instructions to basically set up our remote repository. If we go back to our code, let's see here. I need VS Code again. There we go. All right. So if we go back to VS Code, what we'll do is we'll go ahead and set up a remote. And to do that, we simply type in git remote. And then if you want to check out the commands, we have a git remote and an add. So we want to add a remote's address so we can communicate with that remote repository. And how we do that is we have git remote add. We don't really care about branches right now. but we do care about. We have to give that remote a name. So typically, you would give the go-to name if you have a remote repository. I always use origin, and then we use the URL to that remote repository. So if I switch back over to not display capture, but shoot, there we go. If we go back here, we want to grab this address right here, right? I know some folks probably hadn't set up a GitHub account. Super easy to do. I don't think, yeah, I don't know if, I know John's been pretty active. John, did you set up a GitHub account? Just out of curiosity? Because if you didn't, I can show you how to set one up. Cool. All right. Well, that's what we'll do then. I'll show you how to set up an account. So github.com. I'm going to log out real quick. So sign out. So if you want to set up an account, super easy to do. Actually, once you get on the landing page for GitHub, you can just type in your username, email, and password. And then you'll get a registration email, and then that will basically walk you through the process of setting up your account and then logging into your account. I'm actually going to go ahead and sign in. And then once you do sign up for account, this is the dashboard that you see. The left pane has your repositories. Obviously, as a new account, you won't have any repositories, so this list will be empty. You can actually join teams on GitHub. We have our Free Code Camp Columbus team that we have set up when we want to do open source stuff. Which, by the way, we do have a website and it is open source, and everyone is welcome to contribute. Just to throw that out there. That's pretty much it. I don't know anything else to discuss on the dashboard itself, but yeah. I know some folks are probably setting up an account right now, so I'll give them a moment to set it up, and then once they set it up, I'll move forward. Because I want everyone to kind of catch up. I don't want them to, I'll be almost already done, and it's like, oh wait, I just got my account created, man. Let me catch up. Yeah. Ooh, my neck. I got a really stiff neck, and sometimes if I talk a lot, my neck could get really tight. Sometimes it helps if I squeeze my trap. It's really painful, but oh my god, I feel so much better after. So before I became a developer, I was actually studying to become a cardiac rehabilitation, or what is it? Not a. Well, it's not technically an exercise physiologist, but the folks that run the stress testing. So a lot of the stuff I was learning about was basically how the body adapts to exercise, and learned a lot of cool things about anatomy, like muscle structure, and also how the nerves integrate into the muscles. And what's really interesting is we have this strange phenomena where if we have really tight and tense and painful muscles throughout our body, there's specific points in the muscle bellies. Actually, the points are closer to the actual tendons, So between the muscle and the tendon where they meet, there's these things called trigger points, and if you put pressure on them, oddly enough, it's a weird phenomena. It actually releases the tension in the muscle, and most scientists don't know why that happens. They have a good idea why that happens, because the tendons themselves, if there's enough pressure that's put on them, it causes the tendon. It will. If there's special cells in the tendon that basically, when they sense tension, it tells the muscles to actually relax. And the reason why your tendons do that is because if you're trying to catch something that's very heavy, to prevent injury from the muscle tearing, the tendons just literally tell the muscles, "Hey, just relax, just relax. I don't want you to get hurt." And we're actually exploiting that when we hit those trigger points. It's telling the muscles actually to relax. Extremely painful, but it's really, really good for the muscles. So, yeah, get to learn a little bit more about me. But obviously, this career feels a lot more interesting, if you ask me. Awesome, great, all right, cool. And just to kind of reiterate, creating an online repository. If you're on your dashboard right now and you look off to your left, you should see a button called New. I already went ahead and created that, but after you create the new repository, because there's a couple of prompts that you fill out, but it's not nothing too crazy. You come up to your actual repository and has the instructions here. So it asks us to create a repository. We already did that. Create a README. Not really necessary since it's a very small project, but it's always a good idea to create a README on your repository, so that way you can provide documentation to your contributors. And then you do your commit. We did our first commit, and then now we want to add our remote. So this is what this is the endpoint that our local repository would use to communicate with a remote repository. So I'm not going to type that out. I'm going to copy and paste because I am the most efficient person you ever meet in your entire life. In other words, I'm lazy. So we'll go ahead and add that. Oh, you probably need a CVS code. There we go. So now we create our remote endpoints, and if we do get remote -v, which means, verbose, it'll tell us that, hey, this is the remote repository that we're connected to. Now you're probably wondering, why are there two? That's a very good question, and this is actually really interesting. We'll get into it in a little bit, actually, right after we get our code. But once we connect and push our code to a remote repository, I'll explain a little bit more of what these mean. So the first thing we want to do is we want to essentially um, we want to push our local repository up to a remote repository because we own this repository, right? We have the administrative rights to it. So to do that, we want to use the git push command. What basically git push means is it basically says, hey, I have a series of changes that I have in my local repository, and I want to include this in my remote repository. So you're essentially over the internet connection, you're moving your changes over, right? So git push, this is pushing code, right? So there's another keyword called polling. So polling code means I want to pull down all the changes from my repo, pull it down to my local repo. So we're pulling code down. Here we're pushing code up. Now the pull will get confusing if you're dealing with local remote repositories. And there's these things called pull requests. Don't get confused. Pull requests are actually a lot of people get confused of what pull requests are. But once you understand it, you'll see why it's different compared to just a normal pull keyword. Now you're probably wondering what this -u means. -u means upstream. So what the upstream means is, hey, I want you to keep me updated on. I want you to keep me updated on everything on this branch as much as possible. That's basically what it means. And if you did any pushes, the upstream would essentially, if you did a push, it's basically telling Git that, hey, if I do any sort of pushes, it's going to master, unless I designate a different branch. That's what it basically means. Yeah. So we're going to go ahead and push. It's asking for my content. Oh dear. Hold on here. Somebody forgot to put their credentials in. But I don't normally use GitHub. I actually use Bitbucket. So, but GitHub is still great. It's definitely great for newer devs. So, let's see. GitHub. Oh dear. That's not good. There. Go back to VS Code. I know we actually hit our time, but I want to at least get as far as I can. That everyone's capable. Cool. Yeah, so I'm going to try to push as much as I can to the end. I'll be quick. But if you guys want something explained a little bit more, I'm happy to kind of stick around on that subject and make sure I explain it the best I can. But going back to this, we did go ahead and push up our codes. As you can see, we have our output. A lot of this stuff I wouldn't worry about, but I would pay attention to here. So we basically create a new branch in our repository called master, and master is set up to track remote branch. So now we're tracking master. So if we go back to GitHub, and click refresh. As you can see, our UI changes, and now we have a code repository. We have our master branch and index.html and style.css. But what you notice is we don't have our unordered list, and that's because we only pushed up master. So we'll have to do that specifically after as well. We'll have to push up unordered list if we want to separately. Okay, got it. What branch are you in right now? Looks like I'm in master. I'm still with you, going well. Yeah, we were master. We pushed up master. We pushed it up to remote repository. So, yep. And if we click refresh, we should have our code now in a remote repository. Go back to VS Code. Now, we were talking about git fetch and git push. So, what exactly is git fetch? This doesn't necessarily follow along the lines of what we're doing with our code. Git fetch is basically like a download. of any of the changes from the repository. It pulls all the changes from the remote repository down to our local repository, but it doesn't apply the commits to our local repository. So what that means is when we pull these down, when we do a fetch, we're pulling down all the diff from the remote repository, but we're keeping that in cache. So that way, anything that we pull down, it doesn't change anything that we worked with in our local repository. We can actually take a look first before we actually save what we pulled down. I don't want to get into that too much because now we're starting to get into detached heads or commits that are orphaned. They don't have a branch that they live in. And that could get really confusing, and we don't really actually work over time. But I'm actually gonna provide some resources that you can check out if you want to learn more about how the Git fetch works. It's really good. Atlassian has a really good documentation on Git, and I highly behoove you after this to actually check that out. Actually follow along on the guide, and I guarantee you that you will understand Git a heck a lot more. But yeah. Oh, and also one more thing before I move on to talk about Git flow. Let's say we make some changes to the remote repository. Let's say John or somebody part of this project was contributing, and they made some changes to master, but I don't have those changes yet. So let's go ahead and do that. Let's go to our, and that's the cool thing about GitHub. You can actually make the changes on the fly within the actual remote repository. So I could say something like p hello world, and then I can go ahead and commit the change. So remember, we always leave a message for our commits. So we'll say hello world, and then we don't really need to include a description. We're adding commit directly to the master branch. Commit changes. So this is another commit on our master branch. So there should be 3 commits now. All right, and we go back to. Oh, I'm sorry, guys, you didn't even see that. Apologies. Here, let me do this. Let me switch to. Here we go, and let's go to code. There's a way you can check the history because I want to show you the history. Master. Oh man, I want to see the history. Why won't let me see the history? Normally I know this stuff, but I typically work with Bitbucket or TFS. Here we go. History. I can see I added another commit called Hello World, and I just simply added a paragraph tag to our HTML. Great. Well, this doesn't reflect our local repository, right? We made this in the local repository, and we made this change in the remote repository. So if we go back here, how are we going to pull that down? Okay, well, we could do a git fetch, but we can also be a little aggressive and say, hey, just pull it down and put it in my repository. I don't care. It's small. I don't really need to make any edits, right? So to do that, what we do is we do git pull, so we're pulling code down. We're using our origin remotes, so this is our remotes to GitHub, and then we're designating the branch that we want to pull down, which is master. See? So now you see that we have some output. There's some stuff that are a little bit more technical behind the scenes. We have branch, we are fetching the head. These are the range of commits, master, origin, master. So we pulled it down from origin, master. We updated these commits. Fast forward is simply, think of it like fast forward as just like a fast forward if you're watching a videotape, if you guys know what those are. Or like say if you were watching a movie, you wanted to fast forward to a certain part. We're essentially fast forwarding to this part in our timeline with their commits. And as you can see, these are the changes that we did, and then we had some insertions and deletions as well. Cool. So this is essentially pulling code down. If we want to sync up with the rest of the work everyone's doing, or at least sync up with the remote repository. So I hope that makes sense, because I know that might not, the pull, the push might not make a whole lot of sense. So, jeez, I'm sorry guys. I'm not used to this. Um, Here we go. You can see the output now. So as you can see the a lot of the technical stuff. This is our branch, master branch. We fetched that, and then this is the series of commits, master. Yeah, and then there'll be a pull. We pulled it in from origin master, and then these are all the changes that we did to the repository, and it even has a dictation of all the changes that we did. All right, makes sense? Sorry, I had a cough there. Cool. Awesome. All right. Okay. I know we're 10 minutes over, so I'm going to be really quick with Git flow. I'm not going to go too far into it as I hoped, but just to give you an idea what it is, and why why you should expect this in the work in most employers in Columbus, or most dev shops. So, okay, what is Git flow? What is it? Well, Git flow is actually a workflow that you use when working on a development team using Git. Basically, in a nutshell, Git flow has strict branch rules, but these branch rules center around releases. So a release is basically a set of features that a development team implements into software. And depending on if it's just predefined amount of features that you include, or predetermined time to release these changes or these features to your customer, that's basically what a release is. Think of it like, I don't know, Minecraft. Minecraft has snapshots, but they have their 1.16 release. So that means that Minecraft, at that version of 1.16, these are all the features that they implemented into the game from 1.15 or 1.14. So from that time frame, those are all the features that they implemented in. Now, how does this relate to Git? Well, these branch rules essentially are centered around these releases in a way that they help keep track of those changes. So you have a master, a branch, just like any other normal default repository that maintains the entire history of your code. However, the master branch is actually more of an abridged history of your code. So what that means is it's more of like a cliff notes to your code. What actually maintains the entire history of your code is the development branch. So the development branch is where all the developers on the team integrate the new features to that software. So think of it this way. develop is like the master branch on your default repositories, but it's not something you actually give to your customers. It's and actually master branch isn't something you give to your customers. Master branch is really a cliff notes to the development branch. That's the best way to put it. So what exactly are we giving to our customers, right? Well, we're giving our customers releases of our software. That's how we give our changes. So the releases themselves are the ones that we use for our actual deployments. Okay, not making any sense. That's okay. Best way to put it is you have a development branch. Developers are pushing their features, these feature branches. So these feature branches are the things that you're working on the software, the application, or the code base. You push that into develop. Eventually, you hit once you hit a predefined deadline or you meet so many features according to whatever business structure you're in or business solutions. Sorry, I'm jumbling words. According to what the business needs are, essentially you do a cutoff from development, which is a release branch. So this is the release that we're going to give our customers. You don't touch that whatsoever. The only time you touch the release is if you need to polish up, so like configuration changes, or if you need to do a bug fix for that release, or support. No new features on those releases. So you create that release. Once it's ready, essentially you you finish up the release branch, and then what that does is that basically merges it into master. But master doesn't have all those commits from the release branch. It actually it actually has just like more along the lines of a rebase. So a lot of those commits get cut out, and the ones that get kept are the ones that kind of are more milestones, right? You also generate these things called tags. So think of a tag like you have your photo album of your kid, right? And you got a lot of pictures, but obviously pictures, certain pictures have more meaning to them. Like for instance, your kid is first day of school, and that one picture is them going onto the bus. Well, you might tag that with first day of school, because technically he wants to get on the bus. Well, it's the Department of Education's problem. I'm kidding. I'm kidding. Sorry, that was a joke. But you get what I mean. It just says, okay, this this commit has a special meaning. This commit is the start of the release. So it will tag that commit. It would also merge release into master, but it will also back merge into development because obviously any changes you did to that release, it needs to be part of that timeline for your development. Okay, so just to recap, basically Git flow is it's a workflow that has strict roles, branches that have very specific roles, but these roles center around on the release of the software. That's basically in a nutshell. I really wish I could go a little bit further, but I know way over time. So, and also I'll provide some documentation you can look up and give you a better, much articulate and better answer that I can give on this live stream. So I'm actually going to include that right now with the last scene's documentation. Highly, 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 highly suggest checking this out because it's really good. Excuse me. And also, you want to check out Git's official website too. It's really good. This is like the actual website for Git. And the information might be a little old, but you have to remember Git was originally created by Linus Torvald. I hope I butchered his name big time. I shouldn't have done that, but he originally came up with it back in 2005 because the current version control systems out there at the time, which were more centralized and really The man literally had an animosity to these version control systems. That's why he came up with Git. It was he basically did it. He came up with Git at the spite of the current version control systems. It's great. He was the original meme lord. So, um, yeah, I would highly suggest checking that documentation out. Um, and that's pretty much it. That's all I got. Uh, that is basically Git casually explained. I guess you could say it was casually explained because we did get a little bit in depth in some stuff. So yeah, that's it. Um, you guys have any questions? There was anything that didn't make any sense? Anything that could have been better? Like anything I could improve on? Hey, you're welcome, John. I know it was kind of ad lib on the most part. Uh, so yeah, I'm sorry about that. Uh, there was a couple of spots where it's like, yeah, I just realized that I probably need to install it. Yeah, it's pretty straightforward, especially the Windows installer. Well, actually the command line interface version Linux and Mac are well, Mac's the easiest because it's already there, but Linux you just do a apt-get and then boom, got Git. So yeah, cool. So I'm gonna wrap up. I think everyone's kind of all ready to go, and now I'm all done. My throat's pretty dry, so um, I think there's a couple of things I wanted to talk about before we jump off. I did include the links, so I definitely check those out. Just a shout out to Kent. He's another. Yeah, no. Yeah. Definitely read up more on it because there's a lot of good resources on it, and the more you practice, you want to get a lot of practice. So, and believe me, you want to know about Git when you walk into the interview because they're going to ask you if you ever use a version control system. And if you tell them, yeah, totally, I use Git for all my personal projects, brownie points. Um, well, recently, because Microsoft bought out GitHub, they actually, to promote Azure, they went ahead and, well, you can create private repositories. It doesn't cost any money as long as it's part of your team. So if you created a team in GitHub and then had private repositories associated with that team, it's free. If you don't want your code out in the public. But personally, I think it's a good idea to put your code repositories out in the public, even if you're not too particularly proud of it, because that shows that you have a command over Git, and well, yes, private repositories do cost, but if you create a team on GitHub, you can actually get private repos for free. So used to private repos cost money. It was like $9 a year or $9 a month. I can't remember, but because Microsoft is trying to promote Azure, they're trying to get a lot more people to use GitHub, and they offered a free private repos if you start up an organization. So yeah. Or if you don't want to mess around with that, Bitbucket actually has free private repositories too. So I would definitely check that out if you prefer to keep it nice and simple and just set up private repositories that way. Another great remote repository is a remote repository site is GitLab, because GitLab allows you to do continuous integration. It's already baked in, which is another valuable skill to have when interviewing with employers. I'm telling you, man, if you know version control systems and you know continuous integration, and you at least have a least dangerous with one programming language, you're good to go. So that's just my 2 cents. All right. Man, there's one more thing I wanted to go over. I just can't remember what it was. I can't remember what it was. Oh yeah, shout out to Kent Utterback. He actually had old slide notes a couple years back when he did a talk on Git, and I actually used that in my resource. So shout out to him. He's rich. He did a really good job on that talk too. I wish he would do another talk, but he's busy. Um, yeah, that's all I got. All right, guys. Well, I'm gonna jump off here. I know I'm way over, and thank you so much for sitting through my live stream and listen to me ramble and talk about Git. I know you guys have a lot more important things to do, and it's. I really appreciate you taking time to listen to me and joining in on our live streams. Uh, I know with our current situation with the lockdown, we can't do our in person meetups right now, and uh, just trying to keep the group relevant and letting people know that Free Code Camp Columbus is here to help. I think these live streams are definitely it's something. So, and I like coding. Some people just do it as a means to an end, but I actually like it. I hope by the time I'm 60, I'm still doing this stuff. So, yep. All right, guys. Well, I'm gonna jump off here again. Thank you so much, and I'll see you on the next live stream. I'll talk to you later.